All right, what we're going to do now is take a look at Chapter 3 test of Math 1108, where we've moved into solid college algebra material. And again, these are only the tips of study that you've done as you had your lectures in class, your practice and your quiz me's, and then now what a test might be like. So here we're to determine whether or not this equation represents a function. Now, for background, we say if the x is only used once in a series of, let's say, ordered pairs, then that is a function. So we're looking at this equation, and if we wanted to graph it, we would go y squared equals 4x. And if we wanted to solve it for y, we'd go y equals, we'd take the square root of that, and then plus or minus the square root of the other side. Now, if this were just y equals plus or minus, and keep in mind, if we solve that a little bit too, the plus would be square root of 4 is 2, the square root of x. And we'd also get minus 2, the square root of x. Now, if we were to put that in a graph, the 2 to the square root of x would look a little bit like so. And then this one, I don't know where I got the 3 from there. This one would look like so. So if we did what is called the vertical line test, in which we move this vertical line over the face of the graph, does this blue line, the vertical line, intersect this more than once as it goes over the face of the graph? And the answer is yes, it does. So it does not meet the requirements of a function, and therefore, for our first answer, this is not a function. Now, in example 2, we're asked to state the domain. And again, you've had many examples in your lessons of finding the domain. Well, domain are your x values, and x values that would make the denominator a 0, where our denominator would equal a 0. Those values would need to be excluded from the domain. So, think of any value you could put there. If x were 0, would that make our denominator a 0? No. If x were a negative 2, no, because as we square any negative value, that would make it positive. So, in this particular case, there is no value of x in the denominator that would make it a 0. So the domain would be x equals all real numbers. Now they're asking for your answer in interval notation, and which one matches up with all real numbers. And the answer is letter D. That is, if you put it on a number line, everything is shaded, and it goes from negative infinity to positive infinity. And in interval notation, we use parentheses for infinity. Okay. In example 3, we're given the function. They're saying this is a function, and they want us to find this when we have this function. So we're saying the function of x is this. So we need to take this, which is this part here, and substitute it where the x is. This x right there. And we just write out the negative 4. And we have this x, which is this. And this is the setup of it. So now we distribute, get this, negative 4. Now there's a negative sign in front of the parentheses, so we change each of these signs. And then now what happens? Well, the 3x cancels here. The 4's cancel there. So we're left finally with 3h over h. The h's cancel out, and we're left with 3. Again, this is a little tricky and it's challenging. Now, these word problems, we treated them a little bit in a previous section, but let's look at it carefully. A cereal factory has fixed cost, and it costs this much to produce each box of cereal. A box of cereal sells for this much. So find the rule of the cost function. Now, we had said there are basically two functions, revenue function, where this would be what it sells for, and then the cost function, what it costs to produce each box, and then your fixed cost. So they're asking here for the cost function. So it's this one. And you might say, well, that doesn't match up. Well, it does. It matches up to D. It's just putting the, what I would call the y-intercept first, and then the slope and the x value. Now, for number 5, we're doing what is called piecewise linear functions, where you have a function. Remember, we can always change the function symbol with the letter y, is equal to a negative 4, and they're giving some qualifiers that x is greater or equal to 1, and that y is equal to x minus 3, but the qualifier is that x is less than 1, so 1 is not included in the system. So a strategy for doing this would be set it up like I have done, and then you're going to make a t-chart. Now, this particular equation here is a horizontal line, y equals negative 4, but it's starting at 1, and 1 is included. So we go to x is 1 right there, and it's negative 4, so a dot right there. And then 2, 3, and so forth, and we get a horizontal line going in this direction. So that is this t-chart and that equation. Now they want us on the same graph to plot this equation, and since x is less than 1, 1 is not included. So what we have to do there is we put like a little circle around this to indicate that's where we're anchoring this, but it's not in the set. So we have to mark that a special way. So if x is a 1, 1 minus 3 is a negative 2. If x is a 0, y is a negative 3. And if x is a negative 1, y will be a negative 4. So we have enough points to create a line here, but we cannot include this point on the graph. So instead of putting a solid dot here, we're going to put a hollow dot. So x is 1, and 2. So I put a hollow dot right there. And then 0, negative 3 is right there. And then negative 1, negative 4 is right there. So for this, it says to graph this function, and it happens to be letter A. Worked out very well for us. Now here you're picking them out from multiple choice, and you would have to physically do it on your blue sheet to see which one it is, and you then match it up. But this is the strategy. Take each equation, change the function symbol to y, and get your basic equations, then make your t-charts, and then see what it looks like. Now, as we look at number 6, we're asked to find the function of this graph, y equals the absolute value of this. Now, I've written it in slope-intercept form, where it's y equals mx plus b. So b is your y-intercept, which is right there. And you might say, how come a positive 5 where it should be a negative 5? Because of the absolute value sign. It comes out of there as a positive. So if x is 0, it would be negative 5. The absolute value is a positive 5. So what you do then is you figure out what are your various points. And I made a little t-chart here as well, where I've put some values in. Now remember, every time you put a value in there, like if x is a negative 7, a negative of a negative 7 minus 5, this will be a positive 7 minus 5 would give you a value of a positive 2 here. The absolute value of a positive 2 is 2. And then so on and so forth. So that if x were a negative 5, that becomes a positive 5. Positive 5 minus 5 is 0. And then these values come out always as a positive, so that your vertex of this is right there, negative 5, 0, and eventually your y-intercept would be this. So again, this is a typical shape of a graph that is in an absolute value form. And I believe you have a way to pick this out in MATLAB where you plot the vertex and then maybe some other point, and then if it's absolute value, it gives you the graph. But here you have to match it to what is shown. So again, a word problem as we look at this. It says the population of Springfield is approximated by these two sets of equations. Now from 92 to 2002, it's this, and then from 2002 to 2012, it's this. So we have y equals 2x plus 30. That would be one part of it. And then the other part is y equals 3x plus 20. So the steeper slope is this. This is less steep. So let me just put some lines here to show you. This one is this one up here. And this one is this one over here. Now, as we read the problem, they're asking us to, if the graph where x is 0, and that represents 1992, estimate the population in Springfield in 1999. So how many years is that since then? Well, 7 years. Now, if we were going to look at our graph, and again, they're showing that they've eliminated a lot of the bottom of it that we don't need. We want to go to where 7 years is, which is right about there. And if we were to make a line there, didn't make that too well. And it's going to intersect right about there. So how many would that be? Well, if we were going to guesstimate, and looking at what they have down here, to me it looks like this one. So 44,000. That happens to be the answer. But is there a way to check it? Yes. The equation we would use is this one. So we just go 2 times 7 here. We're saying our year's 7 plus 30. So that would be 14 plus 30 equals 44. So we did it by guesstimating it from the graph, or actually using the appropriate equation. So as we start to work, example 8, we have marginal cost is $100. 50 items cost this much to produce. And if we look at the cost general formula, remember it's in slope-intercept in a sense, we know that this is what y would be, or the eventual cost. We know the marginal cost is 100. And we're going to produce 50 items. But what we don't know is our b. So here we're going to solve for b. So this is 5,200 equals 5,000 plus b. We subtract 5,000 from both sides, and we get that b equals 200. So now we have our formula. C of x is equal to 100x plus 200. And that looks like letter B. And they give you part of the information, and where you go into your tool bag and say, what tool can I use to get to the answer? Okay. And it's nice to have an easy one here. Here we know it's a cost function. And the fella charges $60 per hour. And that's the number of hours. And he has a fixed cost of $95 to get to your house. So that one's pretty straightforward. I get it. Nice to have an easy one. Now in number 10, they've asked us to determine the vertex of the parabola. And we can find the vertex of a parabola by using the Vertex Formula, which is a modification of the quadratic expression in which the h and k are your x and y coordinates of the vertex. So, to do this, we have this equation. Let me set it up here. X squared minus 12x. Now I'm going to move the 38, which is the c term, over here for a moment. And then I'm going to use the technique of completing the square of this to convert this to the vertex formula. So, to complete the square, I put my x there, the negative sign there, and half of 12, which is 6. And then this will give me the item that I need to square to get my c term here. Square that, and that gives me a 36. But I've added 36 here now, so it's not quite the same. But I can also then subtract 36. So now this and this is equivalent to this, which is what I have here. But now I've put this into a perfect square trinomial, and then I just have to do this subtraction here, and I get 2. I now have it in the vertex form. So what will be my h and k? Well, if you recall, it's the opposite sign of what's here. My h is going to be a 6, and my k is just the 2. And it looks like I have the answer. What is the vertex? It's this. And again, this one was sort of easy, but a lot of background needed in order to get to the answer. And how about an easy one? State whether the parabola opens upward or downward. And the key to it is ax squared plus bx plus c. Is your a term negative or positive? If your a term is negative, it opens downward. If it were positive, it would open upward. All right, that's a good one. Now for number 12, we're going to look at this carefully. It says, find the rule of the quadratic function, which is the equation, whose graph has a given vertex and passes through a given point. Well, we know the vertex, and we know one point. Now, what's the strategy of getting to one of these equations? Well, first of all, let's see what we can get from the formula if we do a little substitution here. So we know that in this form, this is y equals this. And since this and this are equal, y equals that, which is the vertex formula. So they're saying that y is 4 over here, so we can put the 4 there. We don't know what the a is yet. And we know that the vertex is, the x value is 5, and there, our x value there is 4, so this x is this 4, minus this x, which is 5, that we're going to square, plus, and then our y value is 2, which is part of the vertex. Okay. So we're just substituting this information into this formula. We don't know what a is yet. We're going to solve for a. So we now have then 4 equals 4a. Well, take a step back. We're going to do this first. It makes it a lot easier. We have to square whatever we get out of here, a -1. So a -1 squared is 1. So this is 1a, or just plain a. That makes it much easier. Plus 2. So we then transpose the 2, and this gives us 2. So a is 2. Now let's see what we have. So we now have, going back to our original vertex formula, we have what a is. A is 2. So we expand this and get 2 times x squared minus 10x plus 25 plus 2. Distribute the 2, and we get 2x squared minus 20x plus 50 plus 2, and now we get our answer. 2x squared minus 20x plus 52. So it looks like letter A. And how did we do it? Well, again, lots of tools from our toolbox. We had to know this, we had to know the vertex formula, we had to solve for A. And once we found out what A was, we were able to go back to the vertex formula, expand our binomial, and get our answer. Okay, lots of stuff on that one. Now for number 13, we're looking at our A term out here. Notice this is in the vertex formula, so we know our A term is negative, so this one's out. And this one's out. And we know that this is our x value, or I should say our y value, of where our minimum will be. So it could be this one, or it could be this one. Then we look inside. So what is the vertex from that? Well, it's the opposite value. This is our h value, which is going to be a 1, and our y value is a -3. So 1, -3 is this one. So just by looking at the graph and recalling that this is the vertex formula, our A is negative, so it opens downward, and then picking out our vertex, we are able to spot that. And here's an easy one. He owns a repair shop. His cost function is this. What is the cost of operating the shop if he repairs this many? It's just a matter of substitution. Put that in your calculator and you get letter D. All right, for number 15, given the following revenue function, find the x value that makes revenue a maximum. Now, for number 15, they're asking us if this is a revenue function, find the x value that makes the revenue a maximum. Now, if you set this up in slope-intercept form, converting the function to y, then we find that this parabola is going to open downward because a here is negative. So we're looking for some value of x. Now, there is a formula which is in our toolbox, hopefully, which gives us the h value of the vertex, which is our x value. And if we put this into standard form, we can identify our a term as -3, our b term as 78. So let's do some substitution. So it's negative b, so a -78. Now a is a -3, so 2 times -3 is a -6. And we do our division here and we get 13. Ooh. And there is our answer. So our x value here for the maximum is 13. Keeping in mind that when you take a test, you're bringing in information that you've worked on and studied. And here I'm not just bringing that in, but trying to give you some more background on what's going on. So if you had this function that you were to graph, and it was y equals x to the third power, it would look like this. Now, here we're saying y equals x to the third power minus 5. So what does it do? Now, in a sense, this is our y-intercept out here. So it will shift this down to the 5. 1, 2, 3, 4, 5. And looks like that. And there we see it right there. So again, you are asked to either sketch the graph or see which multiple choice item it is. So in 17, they're asking us to look at this graph, and if it could be a graph of a polynomial function, which it is, and in a sense we're asked to find the zeros, and up to what point could it be, to what degree? Well, as it finds the zeros, there's one there. Not getting a line for some reason. There we go. One there, 1, 2, 3, 4, 5. And this could come back, and that could come back. So we know it's at least 5 and could be more. So answer B. For number 18, what I did is I put this in my calculator, my graphing calculator, and I'm assuming you have some sort of tool on MathLab if you get one like this. And this is what the graph looks like. So as you can see, it is between 2 and 4 seconds here when you look at the graph. And for number 19, we're looking for the vertical asymptote. And generally speaking, if you have an equation where there's something in the denominator, if you equal that to 0, you get x equals 5, and that is your vertical asymptote. That was an easy one. All right, let's go on to our last one. And as we look here at this, this is our cost function. And we want to produce 10 units. So what we need to do is find the average cost. So we put 10 there. And then this gives us 1,500 divided by 60, which is 25. So 25 would be the average cost per item. And how many items do we want to produce or get? 10. 10 times 25 is 250. So in taking a test, you see you have some pretty heavy things here, and you want to know what tools, what practice, what quiz maze have I done to give me the right to do well on this test as we study the material. Well, knowing various techniques, having various formula tools available to you gives you the right to do well on this test, knowing what they're asking for. And again, hopefully some of them are easy. All right, well, good luck.